I'm Pratima Singh. I'm a solutions architect in the FSI segment. I work with financial customers, and I'm joined by Chris, who's basically done all the coding, so all the questions go to him. And he's a security specialist solutions architect, and we both work with customers in Australia. So we've come really far to tell you more about GenAI, as most of the people here have. So now let's talk about, as a security operations team, and I saw a few hands here, what are your main challenges when it comes to working with data? What is it that you could do with generative AI as a use case that could make your lives a little bit easier? What? Triage. So what all goes into that triage function? Log analysis. Yeah, you heard the keynote, I guess, today. What else? Historical tickets. Awesome. What else? What? Threat intel. Yeah. Anyone else have anything else?
Automation of remediation statements with engineer statement
Like, I'm happy you guys are saying the things that are going to appear in the slides ahead.
Good volume.
So it's good that we're all on the same track and we've all set the baseline well enough. Now, security operations is essentially a very human-intensive function. And we heard our CISO, or the AWS CISO today, talk about how log analysis is the most expensive in terms of time and in terms of human effort as an operation, because of the amount of human hours it takes, as well as the amount of data that you're meant to churn, and the cognitive load of having to interpret that information to make sense of it. Because you could have rows and rows of data and not know what to do with it. And you'd be spending hours, if not days, trying to figure out what is happening in your environment. How good it would be to offload that function and enhance it with generative AI. So what do you do? Say if you see a guard duty finding that's listed on the screen here, an IAM role associated with an EC2 instance gives the EC2 instance some temporary credentials that have now been taken and used outside the instance. Where would you start when you see such a finding and you need to remediate it or figure out what's happening? It's not going to work if you don't answer, because we can't move forward from here. CloudTrail, to do what? To look for API calls, yeah. How do you know that you have to go to CloudTrail? Like, you would have a series of steps listed somewhere, like a playbook? Yeah. What do you do after CloudTrail? What are you trying to establish that, yes, what APIs it has talked to? What happens after? What next? They're louder than us. That can't be right. Sorry, what did you say? Louder.
Check to see if the actual role that needs to serve.
Correct. Check to see the role that has been given the permissions. What do you do with the IP address of the instance? Do you want to make sure that this particular instance has not talked to any other or not made any outbound network connections as well? Wouldn't you? Right? Because I could use those credentials to do anything in the account as long as I have the permissions to do it. So you use CloudTrail, you use what else for the IP address? Flow logs, yeah. So we've already got 2 log sources here, and there's obviously business context on what kind of account this is coming from. Is this EC2 instance even important to us? Is it mission critical enough to wake up at 3 a.m. and fix it? What else? Has there been any historical events with the same EC2 instance or with the same IAM role or similar trend that you see in your environment? What risk does this present to your environment? Yeah? And how do you evaluate that risk? Data inspection. Data exposure, yeah. What is it exposing to, or what can be infiltrated through the instance, right? Who do we need to inform? Where are the humans in the loop? Do my managers need to know about it? Is it critical enough that the PR team needs to know about it, or the legal team needs to know about it? And what other actions do we need to take? So all of this is very much humans keys on board, keys on keyboard, doing stuff in their environments, right? When you think about generative AI as a solution, you look at these aspects becoming separate agents, right? You can build agents to handle these tasks, starting with incident response playbooks, interpretation of the incident response playbooks, looking at the business context of what's important in this particular situation, and also connecting that business context back to the kind of finding that you have. Looking at log analysis, we've already established it as one of the most painful tasks. And doing what with those logs? You get rows and rows of information. If you run a SQL query, say, on your log, what happens then? You have to make sense of what is happening, the trends, the insights through those logs. You want to establish your infrastructure state? So someone said, what have those credentials done in your environment? So you're establishing whether new things have been created or some things have been taken out, right? Is there persistence that's been established? And then finally, historical view of, have we seen this trend before? So it pretty much lines up with what we're going to talk about. The things in red, the little blocks of red is what Chris will demonstrate and showcase how you can use generative AI to augment and enhance these functions in your environment, reducing your time to respond and your time to act, so that you as humans are more a supervisory function as opposed to, I'm going to spend hours doing grunt work to find out what's happening in my environment. Now, there's 3 important aspects of when you build an agent. The first one being what kind of agent or what are you using to build the agent. A few weeks ago, AWS released the Strands SDK, so we're going to be using that to build the agents out. The second is what's the provider for the LLM? The LLM that you're going to use, or the large language model. We've used Amazon Bedrock because it gives us a range of LLMs to choose from. And finally, what kind of interactions do you want, or how do you standardize the interface of interacting with that agent? So you must have heard about MCP, yes? Yes, I did see a code talk yesterday about MCP, so I'm sure some of you were there. So yeah, Model Context Protocol is one of the ways to standardize interactions with your agents. And with that, I'm going to hand over to Chris, who will take you through these use cases that we've discussed. We're going to start with a simple use case of a very basic agent, and then it'll slowly evolve into a more complex use case.
Thanks, Fatima. Hi, everybody. Just quickly, by show of hands, who's actually used the Strands Agents SDK? Only one person. OK, cool. Then that's great, because then we all get a new experience of doing this together, OK? So there are 4 things that we're going to go over today. We're going to build firstly, we're going to build a basic agent that just does pulling business metadata based on an account number. We're going to do that just to level set to show how we're going to build a very basic agent using Strands agents. Then we're going to take the knowledge that we've acquired from that and we're going to apply it to a log analysis agent. And that's where Security Lake comes in, and we'll pull out some records and get some context out of that. Thirdly, we're going to look at how do we then, with those 2 agents, how do we orchestrate across them? So in an incident response context, maybe we want to do both of those things. We want to do some log analysis and we want to marry it up with some business context. And then lastly, we're going to look at using one of the native tools within Strands Agents SDK to poll infrastructure state in our environment. So without further ado, let's talk first about that metadata or business metadata lookup agent that we're talking about. So what we're going to do is we're going to define a tool. And in our case, our tool is going to be using DynamoDB. And there's a bunch of records that we've put in there. But it doesn't need to be Dynamo. You could have ServiceNow, or you could have any other CMDB of your choice. And what we're going to do is define an agent. We're going to give it the tool. And we're going to tell it how to use that tool. And I'm going to show you some of that now. If you can all just make a little prayer to the demo gods before I start, I'd really appreciate it. OK, cool. So what I'm going to show you now is the first thing we need to do if we're looking at doing a Strands agent is we want to install the libraries that we need, the packages. So I'm basically just pip installing Strands agents, and we want to use the tools from the Strands agents packages as well. Now, to define a Strands agent, get it up and running, it needs 3 things. It's super basic. So when we instantiate it, we need to tell it what its job is. We're going to give it a system prompt. We're going to tell it what model it needs to use. And we're going to tell it what tools it's got available to it. That's pretty much it. That's why Strands Agents SDK is super easy to set this stuff up and get them going. So I'm going to show you now, I'm going to set up a very basic agent. I'm going to define a tool first, because I can't define the agent without having the tools available to the agent first. And I'm just going to quickly show you in... actually, I'm not going to show you that then. I'll just bear with me 1 second. Here we go. So you should be able to see. Right, we've got Dynamo. I've got a very simple table I've set up called AWS account metadata. And if I have a look in Dynamo, Dynamo just keeps an unstructured list, unstructured bunch of records for me. And if I have a look at one of the records, it's an account number you can see at the top, and there's a bunch of tags. You know, it's business critical, false, data classification might be internal. It's whatever. It's the stuff that you'd see in a CMDB, right? So what I'm doing with this Strands agent is, firstly, I'm importing the stuff that I need to create the agent. I'm importing agent and tools from the Strands package. And what I need to do is I create a session into Dynamo as you would with Boto 3. But then what I do is I define a tool, and I use the @tool decorator to tell Strands agent that this function that I'm about to define is a tool that the agent can use. And I give the function, I give it a name, get AWS account metadata. And the magic here, or the secret sauce, is the doc strings. The doc strings is what tells the agent how to use this particular tool. And you can see in this case, the first bit of the doc string says it retrieves metadata about an AWS account given an account ID. Now you can expect to use an account ID, to give it an account ID as a parameter, and you're going to get back a dictionary that contains metadata. So now the agent knows how to use that tool just by that doc string. Now below is a bit of Boto 3 talking to Dynamo, but it could be anything. The agent doesn't care how the implementation looks. All the agent cares about is the interface that it can use to talk to it. So I'm going to create this tool now. And now we've got the tool, we want to create an agent. I'll bring that up a little bit so it's easier to see. We want to create an agent that we tell it the role, and we say, you're a helpful agent that looks up metadata about an AWS account. This is going to be our metadata agent, and we give it the tools. Now you might be wondering, well, you said that you need to have 3 things. You need to have a prompt, you need to have a tool, and you need to have the model, right? Well, by default, when I instantiate this agent, by default, the Strands agent's SDK automatically uses Claude 3.7 Sonnet. So I can interrogate the agent, and I can pull out the config of the model parameter for that agent, and it's telling me it's Claude 3.7. Easy. So I don't need to define it every time. You could plug in your own Bedrock model. You can even use a bunch of other APIs to go and call other models, like LLM and things like that, to go and broker access to other models. So we've got our model set up, right? I used to say it's 3 lines of code. In actual fact, it's only 1 line of code that we split over 3 lines, right? So there's 1 line of code to get an agent up and running. So now what do we want to do? We want to say, okay, I want some information about this account number. So tell me about account. Now the agent runs off and it says, oh, I'll look up the metadata for you. I know that I need to use this get AWS account metadata tool, and it goes and provides the account ID, and I get all this metadata back, right? It's basically using the tool and then formulating an answer for me. Now I could just as easily say, tell me about the city of London, make it short. Now it's telling me, okay, I need to clarify something. I'm designed to look up AWS account information. Now because LLMs are very non-deterministic, half the time I do this, it tells me about London. The other half, it doesn't. It won't let me do it. So I was really hoping it was going to tell me something about London this time, but sure enough, the demo gods aren't with me today. But the point I was going to make is that what we need to do is that we should be trying to constrain this as much as possible, both in the tool and in the agent, so we have less chance that things could go wrong, right? So you'll see above here, I've told it like, you're a helpful agent that looks up account metadata, but I haven't told it really anything about what it should and shouldn't do, right? So what I would do, if it was going to tell me about London, which I was hoping it would, I would say, you only respond to questions about AWS account metadata. Politely decline to respond if given anything else. And then I just like reinstantiate the agent with the new prompt. Now, the other thing I could do, I could say, tell me about AWS account 123, right? So that's a constraint that we put on the agent itself about what it should and shouldn't do, right? But now we're saying, tell me about account 123. And it goes, oh, yep, I'm happy to look that up for you. Let me go and use the tool. It knows nothing about AWS account IDs. It's just plugging in a number and hoping for the best. But what we can do now is, this is an example of when we define our tool, we weren't that specific about what the input to our tool was. We said it's an account ID. Sometimes it might know that an account ID is 12 digits long. Sometimes it wouldn't. But let's be explicit for it, right? So an account ID will always be 12 digits. And then sometimes it's good to give it an example. Here you go, there's 12 digits, right? Now, because this is a tool, I'm going to recreate the tool, which will just kind of clobber it. And because the tool needs to be plugged in at the time that we instantiate the agent, I'm going to like reset that agent. Now I'm going to do the same thing again and call it with 123. And now it's saying, you know, I need a complete AWS account ID. Now, the point that I'm showing you this is that when you start to build agentic systems, and a lot of them rely on each other, you want to try and make the interfaces as clean and as reliable as possible, because if one of them makes a mistake, that can then cascade through. But the way that these agentic systems work is that there's lots of loops that go on. So it'll try something, it might get a response that it doesn't expect, and it learns something from it, and it will go, oh, the account number's wrong, right, I'm going to try again. So if you design kind of constraints and kind of control, if you will, into it in this way, it makes your lives a lot easier. Right, so now that we have done a simple strands agent example using metadata, let's take what we've just learnt and let's make it a little bit more complex. Now, we're going to look at how we can use agents to now interface into Security Lake, pull out data, and then do some analysis for us. Who here has used Security Lake, or who uses Security Lake in their organization? Many people? Okay. And who here uses Athena? Everybody should be using Athena, right? So Security Lake is our fully managed security data lake service. It collects logs from all of our security services, centralizes them and normalizes them using something called the Open Cybersecurity Schema Framework, which is basically a framework for rendering security data in any which way you want, right? Any form of security data can be rendered using this or normalized using this. It's not just for our security services, by the way. So third parties can also have their data put into Security Lake in OCSF, and you can also bring in your own logs as well. But the way that we interface into it is we use Athena, because at the end of the day, these logs are going into an S3 bucket in iceberg format, and we have Athena, which is our SQL service that allows us to do data queries on S3 and different data formats, right? So Athena's our way in. But the interesting thing about Athena is that it's an asynchronous service. So if I want to run a query, it won't just respond to my query straight away. When I run a query, I provide Athena my SQL. It will go off and run the query, and it will provide me a query ID. I then need to check on the query to see when is it succeeded. Once it's succeeded, I can then get the results. The reason is some queries might run for 10 seconds, others might run for 10 minutes. So we have an asynchronous method. The reason I'm telling you this is because it becomes very important when we're talking about agentic flows, because the agents can't sit waiting for things to happen. They need to go off and continue to do stuff. So just keep that in mind. Now, I mentioned OCSF. OCSF is very, very powerful when it comes to these agentic workflows. And the reason being is that these agents, because we're representing all this different security data using OCSF, the agent only needs to understand OCSF. If we had VPC flow logs and we had Palo Alto logs and we had all these different logs and different schemas, the agents would have to understand all the different schemas and how these things relate to each other. And it becomes really important when you get clashes where you might have an account ID where one table says it's a string and another table says it's what? Who's listening? An integer, right? That happens all the time. So OCSF has standard attributes, standard objects, and we'll kind of talk a little bit about that. So this would be a typical OCSF log, right? Would have up the top, you can see we've got a findings category, and findings might be different to API activity, for example, as a category. We should be able to capture all our security events using OCSF. Then we've also got our detection finding as a class, which is an event type within the findings category. You could think of it as detection finding is different to a vulnerability finding, for example, but they're under the same category. And then we've got objects to represent more complex data structures. We've got here an example of the guard duty product, which has got name guard duty. It's got a UID of where that guard duty instance is in an account, in a region, et cetera, and vendor is Amazon. But the attributes are always the same. An IP address will always be a string. An AWS account ID will always be a string. Like, these are the things that are important for the LLM or for the agent, and I'm going to use those terms kind of interchangeably, because it knows what to expect. It makes it really easy for it to understand the context sometimes as well. The other thing that's really important to talk about is the notion of observables. Observables is a feature of OCSF where the important security information in that event record is not only in the event somewhere, but it's captured and put in the observable field. And the reason it does that is so that it's in a location that we can easily search. I'll give you an example. Say we've got one product that's identified a username in some log somewhere. Oh, that's interesting. I'm going to put that username as an observable attribute that I can then find across all different event types. So this is important because of an example we're going to use in a minute, where we're going to be looking at this observables field so that we can find things across tables and that. Okay, so let's get back to doing some code. Okay, so because I said that we need to use Athena, Athena's got some quirks about how you call it asynchronously. What we've done is we've just written a very quick and dirty Athena client in the back end. And the idea is that we're giving the tools the ability to execute a query, check on a query ID, and then finally get the results. It means that it's just a reusable component that no matter which tool we use that interfaces with the security lake table, we've got an easy to access library, right? So what I'm doing, and the benefit of this is that I can pass it a AWS profile. So this tool is running in a different context, user context, than what the agent itself is. So we can use this to scope down permissions just for this tool use. So this is an important thing, right? It's good for least privilege. So I'm going to just create our Athena client. I'm telling it that our database is our security lake. It's in AP Southeast 2 in Sydney because we're from Australia. Most of these examples are going to be Australian-based. And I just want to give you just a very quick, for those that haven't used Athena, I'm just going to give you a very quick overview of how this kind of works, right? So in this cell, all I'm doing is I'm saying select everything from the CloudTrail table, but I only want 10 records. Very, very simple query. And then I'm going to use the Athena client, start query, to execute that query. And you'll see here, I get back a query ID. So it's gone off and run that query. It's asynchronous, I've got a query ID. Now I just need to check whether it's succeeded, failed, cancelled, or it's still running, perhaps. So all I'm doing there is I'm just checking the query ID. It's saying it succeeded. It was going to succeed very, very quickly because it's such a small query anyway. And then finally, let's go and get those records by calling the get records function with our query ID. Goes and gets them, and then you can use, I just kind of use some pretty plugin to show you that here are basically all those records in OCSF format. It goes on and on and on, right? But I'm just using that as an example because then we're going to talk about it in more detail. So now let's build a tool that allows us to do an IP lookup from a guard duty finding. So that guard duty finding that Pratima talked about will have some IP address, some suspect IP address in it. And now what we want to do is we want to query CloudTrail, and we want to look for that IP address to see where it's being used across our environment. So what we're going to do is we're going to do the same thing that we did before. We're going to use the @tool decorator to define a tool. We're going to call it IP lookup query. And in this instance, we're going to give it an IP address. We're going to give it days back, which is a period in time to look back to. And also we're going to give it the table name. Now, you might be asking, well, if we already know it's going to be CloudTrail, why would we provide this as a parameter? Because this is a good example of a function that we can reuse, right? Today we might want to plug in CloudTrail. Tomorrow we might want to plug in VPC flow logs. The next day we might want to plug in Route 53. We say Route 53, but Route 53, right? Same deal. So again, we're using doc strings to tell our agent to query Amazon Security Lake CloudTrail data for a specific IP address. You're going to plug in an IP address. You're going to tell me how many days. You're going to use how many days back, and you're going to give me the table name. The logic here is pretty simple. All we're doing is we're just checking that it is a real IP address, and then we're just doing some SQL. Now, you don't need to know too much about this if you're not familiar with it, but the point is we're going to pull a bunch of attributes from our CloudTrail table, and we're going to look at that observables area. We're going to unnest it, and we're going to see if any of the observables in any of the records have our IP address in it. And you'll see here, you'll see down the bottom here, we've got, it's really this AND clause. I don't know if this highlights very well. Maybe it will. Oh, yeah. So the source endpoint.ip, you know when I talked to you about OCSF has very specific attributes. Any event record that has an IP address in it, if you want to find the source IP of something, it'll always be in that field, source endpoint.ip. Destination will be dest endpoint.ip, right? It'll always be in those kind of records. That's how what gives it so much power. We know what to expect. And then we're saying not only could it be in there, we also want it to be in the observables. In reality, it should be in both places, because if it was important enough, then it should be in the observables area, right? So I'm going to just create that tool, right? And all that tool does is it takes that query, it takes that SQL, and it runs execute query against our Athena client. Is everybody with me so far? Yep, awesome. And then all we're going to give back to the agent is the query ID, same as we did that demo of before. But the agent needs two other things, needs two other tools. It needs to be able to check the token or the query ID to see if it's finished, and it also needs to get the results, right? So let's go and define those. And these are super simple. They do nothing except call the Athena client. Just passes that query ID straight through, and again, we're using the doc strings to provide the secret source, tells the LLM, checks the status of a query, given the query ID, this is what you give me, this is what you get back, easy. So we're gonna instantiate those. Now is the fun stuff, right? We've set up the scaffolding. So how do we marry all this up? We need to tell the IP lookup agent what its job is and how to use the tools that we've just created, right? So we're going to tell it, your job is used for finding where an IP address has been used across an org. It's for security incident response. And all this contextual information is very important, by the way. If you left off, for the purpose of security incident response, you might not think it's that important, but it gives the agent a little bit more detail about what its actual job is. So it can provide some additional insights, and you might find that you get better results. So we're saying we're going to give you an IP address, and your job is to query Security Lake to find where it might be used. But then the important stuff is that if you use this tool, you'll get a query ID. You then need to use that query ID to check whether the thing's finished. And then when it's finished, you need to go and get the results. I then want you to analyze the results and give me your opinion, right? Now, some people here might be thinking, why are you providing the SQL to the LLM in the first place, right? Like we've seen plenty of examples of AI that it knows SQL very, very well. It's probably got the schema for the CloudTrail table on Security Lake. Any ideas why we're not just letting the LLM create the SQL by itself?
If it's part of it like a known playbook or something like that, or if it's...
Yep. Okay, so that was good. Two really good answers, right? I'll start with the last one first. Because these things are non-deterministic, nothing will guarantee me that the SQL that it gives me today will be the same SQL it gives me tomorrow. And when we're looking at incident investigation, that's really problematic, right? We want to know what we're going to get. The second bit is we've already got playbooks. Hopefully we've got playbooks where we've got blocks of SQL already, and we can easily just plug these in to our agents. We don't have to reinvent the wheel. It also means we can use change control and approval processes to make sure we've got the right SQLs that are given to the agent. If you also think about it, what we're doing is we're also parameterizing the use of the SQL. Now, we've been telling people to do parameterization for a long time because of SQL injection security issues. It would be a bit bizarre for us to then just open the floodgates for LLMs to kind of do the same for prompt injection, right? So we're kind of killing a few birds with one stone, so to speak. That's why we're kind of doing it this way. So we're going to tell the agent, this is your job. I'm going to set that as the system prompt. And then again, all I'm going to do, one line of code, is define the IP lookup agent. And now I'm just going to show this in action by saying, look, tell me about IP address, blah, 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 from 7 days ago, and we'll see what it does. So saying, yep, first I'll help you investigate that IP address. Let me have a look. Okay, yeah, I need to use the tool invalid request exception. That's not good. I know why. Because I left a talking point in here that I forgot to talk about. Yeah, that was a good one actually, because that would have, yeah. So there is a problem with this, and I'm not going to ask the audience about it. The problem here is that this SQL is very open-ended, right? And you get into a situation where if the LLM gets confused or it doesn't have enough information, it may just execute a query that has no bounds. And then it'll go on and on and on and on, right? So one thing that's important is somewhere you need to limit the execution of these things. You could limit it in its prompt by telling it you should always reject anything that's open-ended, doesn't have a time frame or something along those lines. Or you could hard code it in the tool itself. And that's kind of what I'm doing here is I'm going to put a limit of 1,000 records. I'll just double check these ones. That should all be good. I'll reload the tools and let's try it again. Right, so it's now going to try and use that tool. Roll the dice. Yes, okay. So it's now saying, I've initiated the query, I've received a query ID. Fantastic, let me check the status. Let me check the status. Let me check the status. Let me check it again. It's not ready, let me check it. And it just keeps going until it gets the results. So what it's done, it's pulled a bunch of records in OCSF, and it's got them, and it's now analyzing them, and it's working out that based on the CloudTrail logs for that IP address, it looks like it's performed extensive AWS API activity on the 12th of June. It occurred on this particular account. This user agent was used. It's done a whole bunch of stuff. I recommend further investigation to determine if this activity was authorized as it displays characteristics consistent with security, right? So it's done its job. So the agent itself is now using that tool and getting the SQL and performing the analysis. And this is kind of a bit of the pattern here that Pratima brought up, is that we're relying on those agents or their workers to go do their job and provide us some insight. We don't want it to go and query CloudTrail and just give us a table, because that doesn't help us at all. We want it to query the table and provide us the analysis so we can use that with some other tool to get some real insights out of our environment. Okay, so before we get to that, let's switch back to this. So now what we've done is we've created a very basic metadata lookup agent. And we've also created an IP lookup agent. Now, these are great tools by themselves, but we want to orchestrate across these. And this is kind of where, this is the thinking to it. And if you think back to that diagram where we had the like SOC orchestrator, this is this bit now. It's like the main brain of like who's going to pull all the threads together. So this SOC orchestrator now need to use these other agents, and we have this term agents as tools. This is something that they talk about with Strands agents, where we're basically defining that tools description, but all it's doing is it's calling an agent. So agents can use agents, can use agents. And where this becomes really great is you can make them all hierarchical, you can put them in groups, they can talk to each other, they can reach consensus, and then they can provide some analysis back. Like the power for this stuff is amazing. And I think we're still trying to understand where exactly in the security operations world, not just like, SOC day to day, but also assurance, compliance, risk, all these things. How do we use these agents effectively? So let's cut back to this. Right, now, if you've been following along at home, we now have our SOC orchestrator system prompt, right? So this is the brains of the thing. Now, so we're telling it, you're a SOC orchestrator, you're responsible for coordinating our IR workflows. When you receive a security finding from guard duty or other services, you need to do these things. Now, usually, this would all be in playbooks. You wouldn't hard code this into the SOC orchestrator. You'd tell the SOC orchestrator, you need to go and figure out a plan, and you need to go and use the IR playbook agent to help you figure out that plan and then execute it. But in this, for the purpose of the demo, we're just going to hard code this stuff in. So I want you to obtain any metadata associated with the AWS accounts, or maybe you've got, in a CMDB, you might have particular resources that are owned by particular units or products or something along those lines. So get the metadata. If there are suspect IP addresses, I want you to go and find the stuff, what's happening with IP addresses, route the task to appropriate specialist agents, coordinate the investigation, blah, blah, blah. And I'm also going to tell it, here are your tools. Now, again, you don't need to hard code this. You could actually provide the tools to it when it looks them up. You could also do it dynamically. And I'll get to some other crazy stuff a bit later on as things you can do as well. But one of the cool things down here is, in this instance, we're going to tell it always choose the most appropriate tool, but also I want you to summarize your findings and put it into a HTML thing for me. It's mainly for the purpose of this demo because it looks good. But otherwise, you would say, make sure that you record all of the activities you've performed as long as, and with your chain of thought, with your reasoning, put it into some audit trail somewhere so that we can go back over it later. Make sure that things happen as expected, but also we could optimize them. If we collect all of our information so that it's traceable, we could also provide an LLM whose job it is to optimize our processes. Its sole job is to look at the way our IR workflow works and tell me where we could have improved. Tell me where we should have built another tool. Tell me where this could have been faster, et cetera, et cetera. I think you're kind of understanding where we're going with this stuff, right? So let's create that one. Now, this is where we get to the agents as tool thing. This is super simple. We've already defined our agents. And all we're doing here, again, we're defining a function. We're going to call it business metadata agent tool this time. I don't know why I keep changing the names, but just stick with me. We're going to give it the tool decorator, and we're going to tell the orchestrator agent how to use it. Look up metadata about an AWS account. You can use account ID. I've already put in the 12-digit thing like we talked about. And you're going to get a string containing account metadata, right? Look how simple this implementation is. It is literally just call the metadata agent with an account ID, and you're going to get the response back, right? So the agent now becomes the tool, and you can chain these all the way up. And then we're going to do the same with our IP lookup agent tool. Give it an IP address. You're going to get a string containing a detailed analysis of where the IP address had been found and what it's been doing. So let's run that one. And then again, let's, okay, so this one's a little bit different, right? Because you can see here, and I'll just scroll up a little bit. So from Strands tools, which is a different package, we've got a number of native tools that Strands comes with. This one's called file write, and it gives the agent the ability to write files to the disk, right? So we're going to give the SOC orchestrator agent the SOC system prompt that we defined before about what its job is, and we're going to give it those two tools that we just talked about. We're also going to give it the file write capability. what could possibly go wrong, right? Okay, now lastly, we want to get a guard duty finding that we want to run this on. Now hopefully my session, of course not. Let me just go into guard duty again. Now, I'm going to find a guard duty finding, which is one that was first seen 6 days ago. And its credentials for an instance role were used from an external IP address, and we've got an IP address to give it for it to look up, right? Now, I think, okay, I don't want to do that. What you would do usually is that this would all be automated. All of this information would come through Event Bridge. So Guard Duty, which is our threat detection tool, when it detects stuff, it will send it to Security Hub to aggregate, and it will also write to Event Bridge, and you can then pick up messages off Event Bridge and do automation orchestration with them. It's all event-driven stuff. I'm sure everybody here is already aware of that. So what I'm going to do now is I'm just going to take that finding and just do it the cheat way and just put it in a variable and then give that variable to our SOC orchestrator agent and see what it does with it. So I'll paste all that in. It's all the information that you get from your guard duty finding. Now, there is a consent that's built into Strand's agent that if it's going to do something potentially dangerous, it will ask you whether you want to do it. Potentially dangerous is a very grey area, right? So just the fact that it wants to write a file to my file system, it will ask me. So what I'm doing here is I'm just overriding that and just get on with it, right? Because it's going to interrupt my demo. And so now what I'm doing on this last bit is all I'm doing is I'm calling the orchestrator agent and I'm passing it that guard duty finding. Now, this is probably going to be a bit long and drawn out, but I can tell you the history here, or I can kind of walk you through what's going on. So the first thing it does is it's found that there was an alert from a particular account. And because we told it, it needs to look up the business metadata about that account. It's the first thing it does. So it goes and grabs all that metadata. The next thing, and so it works out that, okay, this account is from the sales production account. Thomas Edison owns it. It gives me the OU structure of where it is. It's a confidential account. Tokens expired. Okay. Bear with me 1 second and we'll just run through this one more time. So hopefully it won't do it again, but. Okay, so it's going to go get the metadata again, saying get AWS account metadata. It's got that. Then it's saying let me investigate suspicious IP address. Great. So I'm going to do a query, IP lookup. Okay, great. So I've got a query ID. Now I need to check the status. You know, it's all the things that we kind of went through before. So it's still running. Let me check. Let me check. Finally, before I got to 10, where it was going to time out. Got the results. So now it's got the results. It's getting back the analysis of that first IP address. Now what you can do with these agents is that you can get rid of all of this. This is kind of its chain of thought as it's working through calling things. You can set a flag to say that you don't want any callbacks. So it would literally just sit here and you'd be waiting for it to do its thing. But I've kind of left this on so we can all kind of see it in action. But what happens is it's done this analysis on one IP address, but it's seen that there's actually another suspicious IP address in the same guard duty finding. So now it's gone back to the tool, and now it's using a different IP address and scanning through looking for this IP address. So this is trying to show that the SOC orchestrator will keep flipping back and forward to the different tools depending on what you tell it. And because we told it, if you get a suspicious IP address, use the IP lookup tool. Every time it finds one, it starts using the other tool, right? So that one was a bit quicker. It's getting the results. And now it's doing an analysis of a different IP address. And this time, it's saying, the log shows a systematic pattern of approximately 146 API calls. Nearly all of them were in a failure state, indicating lack of proper authorization. Systematic nature suggests automated tool performing broad service enumeration. Like, this is all of it understanding, like, from its training data, what this means in a data set. Now, this analysis, you could even augment with your own data, right? And what I mean by that is, if you see this kind of pattern, it must mean X or it must mean Y. You don't leave it up to its own training data for it to figure out what something means. You can make it relevant to your environment. Or how about this? What about all your existing incidents of what were signals from those and what were the results of those? If they were fed into this, this could say, oh, I'm seeing a pattern that we saw about before back in September in 2023, and it was because of this thing. So you can start to augment the way that this works with your business data, with your SOC intelligence data, and your other audit records, that kind of thing. So it's basically saying, yeah, I've found about a number of security concerns, blah, blah, blah. It's all of its chain of thought. And then lastly, it goes and writes us a file. And in case we didn't get it, it still just keeps churning out text because it loves to do that. So let's go and have a look at that file, which it just outputted. And we can show a preview of it. And so this is the document that, so this is the report that it wrote. It says, this is our security incident response summary, incident ID. So it gave it an incident ID. I didn't even tell it to give it an incident ID, right? Saying severity is high, this is the account number, it's production, it's critical because of a whole bunch of tags that I found in the business metadata, such as it's internet facing, this is the owner. Here's a summary of the incident. Guard duty detected it. We've seen 2 IP addresses, but these 2 IP addresses from Perth, Australia, breaking it down as what the attack activities were. The attacker conducted systematic reconnaissance of AWS. One IP address performed 131 successful API calls, but another one did 146, but 144 were failed due to permissions. Like, this is a lot of insight just from a bunch of records that pulled out of CloudTrail, right? And it also gives me some recommendations, which I probably won't listen to. But if we plugged in our playbooks, they would be legitimate recommendations based on our playbooks to say, these are the things that you should do, and here's a reference to the section in the playbook that tells you to do them. You know, the next logical flow from this is obviously like containment, and what do we do next? And so now it can go back to the human in the loop idea of how do we get that human back to say, okay, we want to take some action now, and maybe the human should be doing that, or do we script that up so that they can then do that as well? Okay, so then lastly, I appreciate that we're getting low on time. We've talked about that, and then briefly, I just want to show you one other thing, right? We talked about this orchestrator, and we've shown pulling up data out of Security Lake, OCSF, the power of that, and it's the insights that these agents can get, just even from their normal training data, and that's only 3.7. You know, even Claude 4 is even more powerful than this, but everyone's trying to use Claude 4 at the moment, so we're using Claude 3.7. So then the last thing I want to show you is a tool, a native tool in Strands agent called Use AWS. You can imagine by the name what this does, right? It is literally a wrapper, a very, very simple wrapper to the Boto 3 library that allows you to talk to your AWS environment. It's like natural language for your AWS environment. Again, what could possibly go wrong, right? But in this instance, we're going to ask it about a resource ID, and we're going to get it to give us some information about that. I just want to show you that in action. Go back to this. So now, what we're going to do now is we're using the Strands tools package. We're going to import the use AWS tool. We're going to just give it a very simple prompt saying you're an agent, you gather information about AWS, you only perform read-only API calls. I mean, do not use non-deterministic LLMs to do deterministic security control. So just because I tell it, don't do a read-only, only use read-only API calls, there's nothing to say it will listen to what I'm telling it to do, okay? So you need to have controls in the back end around that too. This is your only job. Please politely refuse if anyone asks you about the weather or anything like that. And I just want you to use a particular profile, an AWS credential profile, when making this call. Okay, I'll help you find information about the IAM policy attached to this EC2 instance called Reinforce Code Demo 2. Now, I'm going to use the use AWS, and I'm going to call describe instances so I can find information about the EC2. Then I'm going to get the instance profile off that EC2. Then I'm going to look at that instance profile and look at the role policies. Oh, and I can see that there's administrator access policy that's attached to that instance profile that's attached to that EC2 instance. So based on my analysis, you can probably guess this is not a good thing. Who put administrator policy on their EC2? So this is all just through the use of this AWS tool, right? If you're going to use this, like my credentials cascaded down through the use of this tool. You didn't see anywhere that I told it you need to use the sales profile. There is no guarantee it will use the sales profile. It might use the administrator profile. So you can wrap these things and hard code the profile in it so that it can only ever use that one. So just be mindful of that. Lock it down in the tool use, lock it down in its prompt, make sure it's constrained. And then you would just plug this in the same way that we did all the other agent tools, right? And you can see how you just continue to build these out. Now, if we go back very briefly to the diagram that Pratima put up before, we talked about the business context, we talked about the log analysis, we've discussed and shown examples for the infrastructure state bit. That IR playbooks thing, like we also talked about the history, you know, keeping that history somewhere, getting an LLM to look at optimizing it, so I'm not going to go over that. But the other thing to talk about very, very briefly is your playbooks bit, right? You could keep this as simple as possible. You have an alert type, guard duty, unauthorized access, EC2, whatever. Very simple lookup in a Dynamo table or whatever, and then you get a playbook. But what's more interesting is the kind of semantic search that you could do. So for example, let's say you've got a finding on an EC2, and by the metadata lookup, you determine that it's a PCI workload. And that it's of a particular product that's business critical to the business. There might be a number of different playbooks that intersect on what a team or what an analyst needs to perform. So by semantic search, you could find all of these. And in the diagram, we're using OpenSearch in that example, which is an Elasticsearch. Our OpenSearch service is Elasticsearch kind of spin-off. And you could use that to kind of use semantic search, pull all that playbook stuff together, and then have a plan of attack for incident response end to end. And now I'll pass you back to Pratima.
So what did we learn so far? What's the first thing you're going to do when you walk out this room?
Build an agent. Yeah.
What else are you going to do after you walk out this? What? What did you say? Restrict. You're all wrong. You're going to go to your events app and you're going to give us feedback on this session. That's the first thing you will do because you will forget and then you will be spammed by emails saying you haven't given feedback for this particular session. But if you do like this session, we're doing it again tomorrow at 8:30. So if you've got peers or people you've met through Reinforce who would benefit from this talk, please send them in. It's in the morning, I understand that, but we will probably have some sugar to help everyone wake up. If you want to attend it again, you are welcome to as well. But yes, please go back and see how you can invest into generative AI for security operations use cases and see how you can use your existing playbooks to translate them into some of these agents, which should be slightly easier than building a net new workload because you already have your queries. You already have that frame of mind on how to operate as opposed to building something new. If you want to know more about Security Lake and analytics, we've kind of gone on a spin-off in the threat detection track, and we've We have a few sessions that are sort of building on each other. So we have an Amazon Security Lake universe where you'll see different sessions going into different depths of how to use centralized logs. The one in the purple, the highlighted one is where you're sitting today. So you are here. Everything else is still available for you to go and see. I think the June 16 and June 17th ones are kind of, you're not going to be able to make them. But yes, if you want to know more on how to operationalize Amazon Security Lake with generative AI and other analytics, make sure you attend the session tomorrow. It is also the graveyard shift session, but you never know. You might get something valuable out of it. And that's it. That's all for us. Thank you so much, and thanks for sitting around here waiting for everyone to clear the room. Thank you.
Thanks very much.